Hello guys, today we're gonna presentation on distributed system deployment using replication techniques by Akash Kadam, myself Samir and Tushar Suryavanshi. So let's start. The agenda of this presentation is like we'll be giving introduction about our project, what is our architecture is, how we deployed that architecture, how we connect to the remote database and took the access of it, how the master and slave model will be working. EC2 instances as a backup, we have used the AWS services in this. What are the challenges we faced and the future work? And then we'll conclude the presentation. So in introduction, like we will talk about the multi-tier architecture. So nowadays, all the companies, all the big IT companies are using multi-tier architecture, and they are not using the monolithic architecture because of the drawbacks of the monolithic architecture. And in multi-tier architecture, we can use the application tier differently, web tier and database tier. So basically we can, if there is any issue in any one of these tier, we can easily recognize the issue and we can solve it without touching other two tiers. Also the deployment is very easy and there is no single point of failure. Even if one of the tier gets crash, we can easily resolve the issue and we can like start the whole setup again. So this is our architecture. In our architecture we used Wata router to create the private VPN for our project. Then we used a CentOS for the which will act as a load balancer. We used two CentOS which will act as web server app servers, and then one CentOS which will act as a DB server. We also created one CentOS which will act as a backup DB server, which is our replication local replication server DB. And then we are using one EC2 instance from AWS as our backup, where we will deploy the MySQL dump. So deployment methods, like how we configure our project. So in this method we will first talk about the hardware requirements. So as I told you, we will be using the EC2 instances, multiple CentOSs, and then the necessary application which we need to get installed on it. So in the first step, like the necessary implementation of the software and our operating system, we what we gonna do? So we basically we the vector after configuration will be there to create the private and NAT network, the deployment of two CentOSs which will act as a web application servers, deployment of two servers which will act as a DB server. So why two database servers? The main reason behind is that the replication, which is the main objective of our course project. So one DB server we will use as a main primary DB server, and the second DB server will be our local replication server. Then we will use AWS EC2 instance, and we will use a load balancer because we have two application servers. So what is the infrastructure design of our course project? So basically this is a multi-tier application. So our first tier would be application and web tier. So in this we will, for web applications we will use Apache. So we will install HTTPD packages on our CentOS, and then we will use the PHP packages like PHP FPM and PHP GD packages for PHP deployment. And then we will use the PHP MySQL client to get installed on the app server. The second tier would be the database server, on which we will install the MariaDB. The creation of we will create a couple of databases, we will add the users, and we will grant all the privileges to the users for the desired database. The main thing which we used in our project is like Ansible is, you can automate the things. So basically we installed the Apache, that is the HTTPD packages, PHP packages and MariaDB packages using Ansible script. So what is Ansible? Ansible is basically a tool on which we can write the Python scripts, and we can do just one click deployment, and the whole configuration get installed and deployed easily. So the basically the Ansible server is agentless. It does not require anything or any a specific tool to be installed on the client servers. There are many benefits. Ansible uses playbooks. So basically, we wrote a script in playbook, and then we just deployed that playbook to install the HTTP packages, PHP packages, and MariaDB packages. Nginx, we used Nginx for the load balancer. So we install the Nginx using PHP, and then we just configure the config file of it, and we configure the load balancer. The next presentation will be given by Akash.
Okay, so moving the main concentration for our project was a database replication. We used a master slave model in our application where we have a master database and a slave database configured. The master database would be the primary database for the architecture, which is directly connected to the app server. Any changes made through the app server in within the database would be immediately reflected into the master database. The slave database acts according to the master database. So whatever database is configured in the master MariaDB, all the contents of that file will be automatically updated in the save database. This will not work in the opposite direction. This is only for is only a one-way direction model. We first employed local database replication where we have two DB servers, our main server and our backup server. So whenever there is a failover or a meltdown of the database, we have a backup to support the app server. Other than that, we regularly and periodically take MySQL dumps as an our backup and update it to the EC2 instance where we have configured another DB server, which gives our architecture that extra security. So moving on to the results, this Wireshark capture is kind of a starting point into ensuring an evidence of a connection happening between our app server and a database server. So as we see, as we have seen, the database server's IP address is 19. We can see MySQL packets going from the app server to the database server. Uh, in order to test the entire scenario, created uh, my own table in my master database server. These are the all the three elements of the database. Immediately after I created the database and committed the process, the database was updated automatically onto the second database server, which is our slave database, as you can see. Uh, Next thing was to upload this update into the cloud. So this is our initial configuration of our cloud based server. As we can see, there are only two databases configured, which are the default databases. After creating a SQL dump file, I SSH my I the dump file to the cloud. After running the MySQL dump file, as you can see, the updated databases are shown, namely the WordPress database. Uh, and moving on, our last testing phase was to test failover. So, in order to test failover, we switched off our a master database server, our primary database, and let all the load go to the slave or the supported secondary database. As we can see from the Wireshark captures, we that as as the master database, which is marked as 19, is off, the packets go to directly to 20 automatically, thus ensuring that we have ample of backup for our architecture. So let's move on to challenges in future work. So the biggest challenge that we faced was the limitations of Amazon AWS, especially the free services that they offer. Our initial pitch was to work on RDS, but that proved to be too expensive for us. So we used EC2 instances, which have very limited access in terms of routing the server, which also hampered our attempts to implement replication on the cloud. There are also various different replication errors depending on the OS versions, and also the MySQL and MariaDB versions, which which we faced. So in terms of future work, there's definitely a scheduled monitoring script that we can write for better performance and security, and for future updating of the architecture. We can configure DNS, a DNS server, and we can also configure DB clustering, which requires completely different types of packages from MariaDB and SQL, which do not support replication and some other essential MySQL activities. Another thing is that we can write scripts in Python or PHP, which can automate the MySQL dump backup to the cloud. So in conclusion, we developed a multi-tier service-oriented architecture with database redundancy. Redundancy basically helps us in ensuring that there's no meltdown in our system architecture. We have ample of backup and automatic replications onto the other database instances, which help in cases of failover and meltdowns. So the biggest lesson that we learned through the project, that a system administrator's role in the enterprise is not only to manage and administer the various company resources, but also help in boosting the performance and reliability of the entire company architecture. Thank you.